Good morning, children. We are in the last part of the same chapter, metals and non-metals. In this part of the chapter, we are going to discuss about covalent bonds. Now the question comes, what is a covalent bond? A covalent bond is a bond that is formed by the sharing of electrons. If you remember, in the last class while discussing ionic bond, I have told you that ionic bond arises when we have two different types of ions, cations as well as anions. Right? Cations are positive charged ions and anions are negatively charged ions. In this type of bonding, conditions do appear in such a way that atoms cannot accept electrons. Okay, the only option left for them is to share. But here also we follow the same octet rule. What is the meaning of octet rule? That is having 8 electrons in their outermost shell. That is the octet rule, or at times we follow the doublet rule. Or either we follow the octet rule or we follow the doublet rule. In the octet rule, what we know, that in case of octet rule, an atom should have 8 electrons in its outermost shell. And in case of doublet rule, that is restricted to hydrogen, helium and lithium like atoms, where it is stable by having only 2 electrons in the outermost shell. That is called the doublet rule. Okay. Now see, here we are going to discuss the first type of covalent bond. So if you want to write down definition of covalent bond, just write it down. It is a type of chemical bond formed when atoms they share electrons. In equal numbers. Atoms share electrons in equal number. Then only they have this condition of covalent bonding. In this covalent bonding, now what we know, that when they share their electrons, they change into molecules. Now when they change into molecules, they have the least amount of energy and maximum stability. That is, they have the least amount of energy and they have the maximum stability. Now see, covalent bonds. Now we are going to discuss types of covalent bond. Covalent bonds are generally of 3 different types. The first one is called as single covalent bond. In this single covalent bond, actually what is happening, atoms actually share a single pair of electrons. In a single covalent bond, the first point we should know, they should share a single electron. Next is that bond is between 2 electrons that are shared. Bond is between 2 electrons that are shared. One example will make it clear to you. See the example of chlorine molecule. We will discuss the structure of chlorine molecule. In case of this chlorine molecule, what we know, that chlorine's atomic number is 17. 17 means it has 2 electrons in the first shell, 8 in the second shell and 7 in the last shell. As chlorine has 7 electrons in the last shell, so chlorine's tendency is to have the stable octet by accepting 1. But the problem is that if there are 2 chlorine atoms, suppose we have a chlorine atom and we are drawing the electrons of the outermost shell. So chlorine has 7 electrons that we represent by the help of these 7 dots. Can you see? that the chlorine has 7 electrons in the outermost shell. These 7 electrons of this chlorine is represented by these 7 dots. Now when these 7 dots are there in case of chlorine, we have another chlorine atom that also has 7 electrons. Now these 7 electrons this chlorine is also having. Now in this case, what is happening, if the first chlorine takes 1 electron from the other chlorine, in that case it might have its octet, but the other chlorine, as it gives away 1, it will have 6, so it will have 2 less than the octet. So in that case, what we do, only option is to share. So what we see, that this chlorine atom, it has its own 7 and sharing 1. In the same way, the other chlorine is also having its 1 and sharing 1. So how many electrons are involved in the chemical bonding? We could see only 2 electrons involved. So we just represent it like this: chlorine, single bond, chlorine. So this bond is called as single covalent bond. This bond is called single covalent bond. Why is it called single covalent bond? It is called single covalent bond because there is the sharing of a single pair of electrons. That is 1 electron from each chlorine. As you could see in the above diagram, each of the chlorine is sharing its 1 electron. If it shares 1, here also it shares 1. So as a result, it forms chlorine-chlorine single bond. As the result, it is forming chlorine-chlorine single covalent bond. In this way, it is actually sharing its electrons. Okay, that is the formation of a single covalent bond. Is this part now clear to you, children? Okay, children, now we are going to discuss the next type of covalent bond, that is called double covalent bond. That is called double double covalent bond. As the name tells you, double covalent bond means a type of bond where it shares 2 pairs of electrons. So in a double covalent bond, there is the sharing of 2 electrons by each atom. Sharing of 2 electrons by each atom. There is the sharing of 2 electrons by each atom. So it is called as a double covalent bond. Now the next point is that here also it follows the octet rule. Here also it follows the octet rule. That is, each atom has a tendency to have 8 electrons in their outermost shell. One example will make you clear. For example, see oxygen molecule. Oxygen molecule is made up of oxygen atom, right? Oxygen molecule is made up of oxygen atom, and each of the oxygen atoms atomic number is 8. 8 means 2 and 6. 8 means 2 and 6. As it has 8 means 2 and 6, in this case what we know, that each oxygen has 6 electrons in the outermost shell. So we represent the 6 electrons of oxygen by the help of these 6 dots. Okay, can you see? Each oxygen is having 6 electrons, right? See, each oxygen is represented by 6 dots. That is the first oxygen. Another oxygen we have that also has the same configuration. It is also having 6 electrons in its outermost shell. Now what is happening, that each of this oxygen, it has its own 6 and it shares 2. It takes the 2 from the other. Another oxygen also has its own 6 and it shares 2. So how many electrons are being shared? If you count, it comes to 4. So there are actually 4 number of electrons that has been shared. There is actually 4 number of electrons that is been shared. Or we just represent it like this: oxygen double bond oxygen. Why? Because here it is the sharing of 4 electrons, or we call it as double covalent bond. We call it as double covalent bond. In this double covalent bond, as we could see that number of electrons shared is 4, so it is called as double covalent bond. In this way we can just see that these atoms are sharing 4 electrons, hence it forms a double covalent bond. Okay? After that, children, we are going to discuss the next type of covalent bond, that is called triple covalent bond. That is called as triple covalent bond. That is called as triple covalent bond. In a triple covalent bond, there is sharing of there is the sharing of 3 electrons by each atom. As we could see in the previous one, there was the sharing of 2 electrons for a double covalent bond. In this case, there is the sharing of 3 electrons in a triple covalent bond. Next is, here also it follows the octet rule. Here also it follows the octet rule. Here also it also follows the octet rule. Example here we have is nitrogen molecule. Here also we have the example is of nitrogen molecule. Okay, because the nitrogen molecule is made up of nitrogen atoms. Nitrogen molecule is made up of nitrogen atom. Okay, see, this nitrogen molecule is made up of nitrogen atom, and the condition is such that nitrogen will actually share 3 electrons. Nitrogen will share actually 3 electrons, because nitrogen, see, atomic number of nitrogen is 7. 7 means it has 2 in the first shell, 5 in the second shell. 2 in the first shell and 5 in the second shell. So what is happening? See, here I am drawing the diagram of nitrogen. One of the nitrogen has 5 electrons. See, each of the nitrogen, I should say, has 5. We draw another nitrogen that is also having 5. 1, 2, 3, 4, 5. So we have these 2 nitrogen atoms, each is having 5 electrons in its outermost shell. Now what this nitrogen does? This nitrogen has its own 5 and shares 3. Another nitrogen has its own 5 and shares 3. In this case, how many number of electrons it has been sharing? As you could see that it has been sharing actually 3. So it forms actually, that is called a triple covalent bond. That is called a triple covalent bond. Why is it a triple covalent bond? Because in this we could see there is the sharing of 3 pairs of 6 electrons. So it is example of a triple covalent bond. Is this part now clear? After that, children, we are going to discuss the chemical bonding in different types of compound. The first type compound we are going to discuss is the chemical bonding in hydrogen chloride. In hydrogen chloride. We are going to discuss the chemical bond, how it exists in case of hydrogen chloride. As you could see, the structure is hydrogen and Cl. Each of the hydrogen has 1 electron in its outermost shell, and because see, and each of the chlorine has 7 electrons in its outermost shell, because the electronic configuration of chlorine is 17. 17 means 2 in the first shell, 8 in the second shell and 7 in the last shell. So in case of this, what we see, each of the hydrogen has 1 electron, each of the chlorine has 7. In this case, what will happen? The hydrogen will need to satisfy the condition called doublet or duplet. Okay, in this case it has 2. Each of the chlorine shares another 8. So now just seeing at this diagram of hydrogen chloride, what we could see, that it is actually sharing a pair of electrons. It is actually sharing a pair, single pair. Or I could just write the structure of hydrogen chloride as H single bond Cl. This is the structure here. The bond is a single covalent bond. Single covalent bond. That is the structure of hydrogen chloride. Now we have the structure of carbon tetrachloride. Okay. Now we have the structure of, but before that we should study the structure of methane. CH4 methane. See, methane is an alkane. Methane is an alkane which is highly flammable and it has a high calorific value. See, the benefit of methane is that methane is highly flammable. Methane is highly flammable, and the next important point is that methane has a high calorific value. Highly flammable, it has a high calorific value. Another important characteristic feature of methane is that methane has a high calorific value, and as I have told you, it is highly flammable, and it involves simple covalent bond. See about the structure of methane, how to draw the structure of methane. See, in case of methane, what we know, that carbon's atomic number is 6. 6 means it has 2 electrons in the first shell and 4 in the outermost shell. Each of the hydrogen atomic number 1, that is, it has 1 electron. So to draw the structure of carbon, first of all we write the symbol. Then what we know, that each of the carbon has 4 electrons in its outermost shell. There is only 1 carbon, and that carbon is having how many electrons? 4 electrons in its outermost shell. Each of the hydrogen has 1. Each of the hydrogen has 1 electron in its outermost shell. Each of the hydrogen has 1, right? Now in this case, hydrogen need to satisfy the condition of doublet. Hydrogen does the chemical bonding like this. Hydrogen needs to satisfy the condition of doublet, right? This is how hydrogen has, each of the hydrogen satisfies the condition of doublet. But the carbon needs to have 4 more to have octet, so it has this 2. This 2 adds up to 4, this 2 adds up to 6, and this 2 adds up to 8. So in this case, what we see, we get the structure of methane. So in methane, the structure is like this: carbon, single bond hydrogen, single bond hydrogen, single bond hydrogen, and single bond hydrogen. So there are actually 4 single covalent bond. There are actually 4 single covalent bond in case of methane. There are actually 4 single covalent bond in that of methane. That is how the structure of methane exists. After that, children, we are going to discuss the structure of carbon tetrachloride. So carbon tetrachloride, again we draw the structure of carbon. Each of the carbon has 4 electrons in the outermost shell. As we know, atomic number of chlorine is 17. That means it has 7 electrons in its outermost shell. So to represent these 7 electrons, we represent it like this: single dot, another Cl. Here also we have Cl. Okay. Now see, each of the chlorine needs to satisfy its octet. It has its own 7 and sharing 1 from carbon, 8. Here also the same chlorine has its own 7 sharing 1. Here also the chlorine is having its own 1 and sharing. And here also it is having the same chlorine and sharing 1. In each of the cases, what we see, that each of the chlorine is having 8. Now the carbon also has its own 8. So it is forming a type of structure like this: carbon, single bond Cl, single bond Cl, single bond Cl, single bond Cl. So it forms 4 single covalent bond. So it forms actually 4 single covalent bond. Each of the carbon is forming 4 single covalent bond. In this way the compound structure is formed. So here we are actually having 4 single covalent bond. Okay children, that was all for the day. Thank you.